Solve one problem on thermal contact resistance. We will read the given question. A layer of 5 cm thick fire brick is placed between two 4 mm thick steel plates. The face of brick adjacent to the plates have rough solid to solid contact over 20% of area. With the average heights of aspirates 1 mm, if the outer surface temperatures of steel plates are 400 degrees Celsius and 100 degrees Celsius respectively, find the rate of heat flow per unit area and assume that the cavities are filled with air and thermal conductivity of air is 0.02 watt per meter Kelvin. Conductivity of steel is equal to 40 watt per meter Kelvin and conductivity of brick is equal to 2 watt per meter Kelvin.
Let us understand the given question with the help of diagram. It is given that the brick layer is in contact with steel plate on its both sides, and this brick layer is in rough contact with the steel plates. Now if we observe this three-dimensional diagram, then this is the side view from where we can clearly see the thickness. This is the front view, from that we can clearly see what is the area, and this is the top view. Now it is given that brick layer to steel plate contact is 20% of area. So this is the information mentioned in the question. Now area is not given, so we will consider area is equal to 1 meter square, that is we will consider area as a unit. Now out of this 1 meter square area, brick and steel plate contact is 20% of area. So what is the 20% of 1 meter square? That is 0.2 meter square. So we can write here area of brick and plate contact is equal to 0.2 meter square. It is also mentioned that the remaining are the air cavities. So area of air cavities, that is equal to 0.8 meter square. So if we add 0.2 plus 0.8, that is equal to 1 meter square of area. Now we have to first understand how the heat transfer process is taking place through this system. It is given that the temperature at this outside surfaces, that is 400 degrees Celsius and 100 degrees Celsius. Now from this 400 degree, that is this outer surface, how the heat will flow towards this 100 degrees Celsius. Now we will consider here the direction of heat flow. So this is our assumption. So we will consider the direction of heat flow is from left hand side towards the right hand side. Now while drawing this diagram, we have to take care of one thing, that is about the thickness. Now thickness of brick layer is given 5 cm. So we have to show the thickness is 5 cm for the brick layer, and then the thickness of the steel plate is given 4 mm. So here the thickness of steel plate we have to show on the both sides, that is 4 mm. Now when this steel plate and brick layer is in rough contact, that means there are air cavities, so the thickness of aspirates is also given, and that is equal to 1 mm. So we have to show here the small gap, that is 1 mm. But it is also mentioned that air cavities are only 80% of area. So if we observe the top view, then here the air cavities I have shown, and only 20% of area is covered with direct contact of this brick layer and MS plate. So brick layer I have shown here with the help of the inclined red lines. So we can clearly see. So this area is 80% for the air cavity and this 20% for the solid to solid contact, that is plate to brick contact, steel plate to the brick contact. So this is very important information. Now we will draw analogous electrical circuit. So how to draw the analogous electrical circuit? So we have to first understand the heat transfer process. So from the surface of 400 degrees Celsius, heat is getting transferred through this MS plate, that is the steel plate. So we will consider here the steel plate. So the resistance is considered for the conduction heat transfer. So we will consider the resistance for the conduction heat transfer through this steel plate, that is R1. So I will write here, or I will mention here, this resistance will be R1. Now what is happening after that? So again heat will be getting transferred through this air cavities or directly to the brick layer. Now it is mentioned that 20% of area is brick layer, that is there is contact with the brick to the steel plate, and 80% of area to the air cavities. So here when the heat is getting transferred from the steel plate towards the brick layer, then the heat will flow to the brick or through the air cavity simultaneously. So we will consider here that is the first resistance R2 for the heat is transferred through the air cavity. So these are the air cavity. So I will mention here R2. That is the resistance R2. So we can clearly see in the top view. And then the resistance R3 is for the conduction process that is taking place from the MS plate to the brick layer. That is when the heat is transferred from this brick layer. So I will consider here the resistance R3. So this is the simultaneous process, because that is the heat is transferred to the brick layer, through the brick layer and through the air cavities. So these R2 and R3 are in parallel. Now again the heat is conducted or heat is passing through only brick layer in between these cavities and solid to solid contact. So this middle area, when the heat is passing, then we have to consider the resistance for conduction in the brick layer. So I will say this resistance will be R4. Now again the same process is taking place when the heat is passing from this brick layer to these air cavities and here solid to solid contact. So this is also simultaneous process. So we will refer here the same resistance. So through the air cavities we will say here resistance R2, and for solid to solid contact we will refer here resistance R3. Now again the heat is passing through this steel plate. So again we will refer the same resistance R1. Now why we are taking here the same resistance? That is because here the thickness is same, then conductivity is also same, that is material is same, and area is not mentioned, so we have to consider here 1 meter square. So we will refer here the same resistance. Now we will draw the electrical analogous circuit. So this whole heat transfer process is taking place in between 400 degrees Celsius and 100 degrees Celsius. So I will consider this is the temperature T1 and here is the temperature T2. So heat is flowing from left hand side towards the right hand side. So I will take T1 minus T2. Now we will mention the first resistance R1. Now after R1, R2 and R3 are in parallel. So we have to mention here is R2 and here is R3. Then R4 is, we have to show, that is when the heat is passing through this brick layer in between these aspirates, and again there is R2 and R3 are in parallel. So I will show here. And again there is R1, that is the resistance for the conduction heat flow in steel plate. So this is the electrical analogous circuit. Now we have to find out what is R1, R2, R3 and R4. So all this heat transfer process is taking place by conduction. So there is formula, that is R is equal to B by Ka, where B is the thickness, K is the thermal conductivity, A is the area. Now we will find out what is R1. So what is the R1? So thickness, we have to consider standard unit, that is meter. So 4 into 10 raised to minus 3 divided by K. So K for steel plate is given 40 multiplied by area 1. So answer is 0.0001 Kelvin by watt. Now in the same way we will find out what is R2. So for R2 again same formula, thickness. So thickness is 1 millimeter. So for that aspirates, thickness is given 1 millimeter. So 1 into 10 raised to minus 3 meter divided by K, that is conductivity K. So for this air, the conductivity is given 0.02. So I will write here R2 is for air. And then A. So what is the area? So air cavities are 80% of the area, that is 0.8 meters square. So we have to write here 0.8. So answer is 0.0625 Kelvin by watt. Now R3. So here R3 is for solid to solid contact, that is when this MS plate and brick layer is in contact. So this solid to solid contact 20%, that is 0.2 meters square is given. So thickness is for 1 millimeter, that is 1 into 10 raised to minus 3 divided by 2 into 0.2, that is 0.0025 Kelvin by watt. Now we will find out R4. Now for this R4, if we observe this 5 centimeter is the brick layer is given, but we have to take this one, or we have to consider this 1 millimeter aspirates on both the sides. So from this 5 centimeter, that means from total brick thickness is 50 millimeter. So we will find out what is the, excluding this aspirates, what is the thickness of the brick layer. So I will write here thickness of brick layer. So this thickness of brick layer, this total thickness is given 50 millimeter, but we have to subtract the thickness of aspirates on the both sides, that is 1 millimeter plus 1 millimeter, that is 2 millimeter. So which is equal to 48 millimeter. So we have to take the thickness 48 millimeter. So we have to convert it into meter, that is 0.048 divided by K, that is 2 multiplied by 1. So this K for brick layer is given 2. So answer is 0.024 Kelvin by watt. Now we will calculate the heat flow. So if we observe this electrical analogous circuit, we know that heat flow is equal to this temperature difference divided by summation of R. So this R1 is there. Now this R2 and R3 is in parallel. So we have to first solve this loop. So when it is in parallel, so this R2 and R3 is for contact resistance. So we have to take how to find out this parallel resistance. So we will write here formula, that is 1 divided by R contact is equal to 1 divided by R2 plus 1 divided by R3. So when we solve this, then we will get the answer. So if we solve this right hand side, then this right hand side answer is for 1 divided by R contact. So again we have to take the inverse for this answer for the right hand side to find out R contact, and this R contact is equal to 0.0024 Kelvin by watt. Now this is the answer for R contact. So if we observe this, if we solve this loop, then this R contact R1, R4 and again this R contact and R1 are all are in series. So we will take summation of R is equal to this R1 plus R contact plus R4 plus R contact plus R1. Now here it is not necessary to solve this loop because this R2 and R3 both are same. So we have to just take this R contact 2 times because the same values are repeated. So what is the answer? That is 0.029 Kelvin by watt. So Q is equal to T1 minus T2, that is 400 minus 100 divided by 0.029, which is equal to 10,342 watt per meter square. So because we have taken here area as a unity, so we have to take per meter square. So this is the answer for 1 meter square, that is for Q. So unit is watt per meter square.